Hi there, this video is going to walk you through the existence rule for state functions. Alright, so what the existence rule tells us is that we can use the cross derivative test to confirm that a function is a state function. So if the second cross partial derivatives of the function are equal, then the function is a state function. Okay, what does that mean? Well, let's start off with our function. Okay, so we have a function of x and y. If we want to take the total differential, we know that is a dx plus b dy. Okay, so this is just any general function of x and y. Total differential is given by a dx plus b dy. Okay, so total differential, just like we've seen before for our internal energy and enthalpy expressions. Okay, so here, remember a represents the derivative of f with respect to x at constant y, and b is the derivative of f with respect to y at constant x. Okay, so again, this is just like for our constant volume heat capacity and pi t that we had for our expression for internal energy. Okay, so same sort of things we've been working with. Okay, so what this existence rule is telling us is that if the derivative of our derivatives, okay, so if the second cross partial derivative, so essentially dA dy at constant x is equal to dB dx at constant y, then that essentially tells us that f of x, y exists and further is a state function. Okay, so again, remember a and b individually are already derivatives. Okay, so that's where that second cross partial derivative comes in. Okay, so if your second cross partial derivatives are equal, okay, then that function exists and we have a state function. Okay, so we already know that about u and h. Okay, but again, this is the method that you would use to essentially ensure that you had that situation where your function exists and it's a state function. Okay, so let's do an example to illustrate how to use the existence rule. So I'm going to ask the question of, does u of vt exist? Okay, so at this point, we already know that that exists. We've worked with it before. Okay, we also know that it's a state function. All right, so this example is essentially just going to further prove to you what you already know. Okay, so a couple things to have in mind here. We're going to say that CV for this particular situation is 5/2 r, and we'll say that pi t is a over v squared. So right away we know we are not dealing with an ideal gas, right? So we have a value for pi t, or a non-zero value for pi t, so we know that we are dealing with a real gas. Okay, so first step here is going to express our algebraic function in terms of its total differential. Okay, so we're just going to write that du equals cv dt plus pi t dv. Okay, so we already know that's our total differential for internal energy. And now we are going to ask ourselves the question of, does the partial derivative of CV with respect to V at constant t equal the partial derivative of pi t with respect to t at constant V? Okay, so this is essentially our existence rule that we're testing. Existence test. Okay, so now we'll just evaluate those partial derivatives and see what we end up with. All right, so start with this one. So we know the derivative with respect to V of 5/2 r at constant t is just 0. There's no V in there, right? And then how about for pi t? Same idea. Okay, plug in your expression for pi t. And once again, no t in there, so we get a value of 0. All right, so we have the situation where this is true. Okay, so they both equal 0. Our function exists. And we already knew that. So, and it's a state function. Okay, so that's the process that you would go through to verify that your function exists. You'll have a couple of practice problems on your homework for this, but essentially what you're asking yourself is if those cross partial derivatives equal 0, or sorry, equal themselves. Okay, so do some practice with that, and I hope this was helpful. Thanks.